Okay, welcome to Unit 2, Algebra, Unit 6-2, Algebra 2. We are looking at exponential functions, and we're going to have them in vertex form. So what I'm going to have you do is I'm going to have you write down a few templates, and then I want you to just switch over to this graphing calculator. If you're familiar with this stuff, then go ahead and make predictions on the templates and then check it on the calculator, make sure you're correct. If you're not familiar, then you'll become familiar really quick. These are pretty fast and easy. So the first template I want you to do in your notes is changing h. I'd prefer this be on graph paper. Come grab some from me if you need it. The parent function we'll look at is 2 to the x. Then I want you to change the h value. H would be a -4. You'd plug it in. It would become x plus 4, because remember it's x minus h in this format. So when you plug in a -4, it becomes a +4. See how it moves this graph. Now, I will tell you guys, the point that I look at, as I pointed out, is where it crosses the y-axis right here at 1. I use that as my visual point to see how they move when they move left to right. So then I want you to do h is equal to 5. When you plug that in, it would be x minus 5. See how that moves the graph. Make your predictions, make sure and write in a sentence next to the graph how it's moving, because in class you need to be able to explain these. You need to actually be able to stand up and move that direction with your body, be able to graph it anytime I ask, those kind of things. Okay, now we have the k that we want to move. So write down, pause the video, write down this template. I want you in Desmos to enter the 2 to the x, then right below it enter 2x plus 5, then 2 to the x minus 3, and just show on the graph how they are moving. Then we want to change the a value. Same things. Pause this video, copy these down, and right after you get this one done, just pause the video, go over to the Desmos calculator, plug those in, and fill in your notes, how they change. Okay, next thing we do is we're given a graph, and we're asked to find the function rule for the graph. So I just want to show you an easy way to do this. Normally, on the parent graph, the asymptote's at 0. So the first thing I look at is where's the k, and I can spot that by looking at where my asymptote is. My asymptote here is at 1 because this line's curving and not going to cross 1. So I know my k value is 1. So I could go ahead and put a 1 right in there. Okay? Now my a value, remember how I said just a minute ago, I always look at this point because it, for the parent function, is at 1. That is my a value, the distance there. So if I go to where my asymptote is, and I look at the distance up to where it crosses the y-axis, I can see that's 2 units. I don't have my blue pen, so I'm going to have to go 2 in brown. Okay? So it's the distance from the y-intercept to the asymptote is my a value. So I can plug that in as 2. Okay? Now, for b, what I have to do is I have to solve for b. If you remember right, g of x could be written as y. And we have 2 b to the x plus 1. Now the x and the y are a point. And if we look at our graph, we have a point right here at 1, 7. So with the point at 1, 7, we can now plug in a y value of 7, an x value of 1, and we have a plus 1. Now we simply solve. Going up our PIMDAs, we circle our creepy dude, the b value, and we're going to subtract 1 because that's what's being added. We get 6 equals 2b to the first. We're done with add, subtract. Now we go to multiply, divide. Divide by 2. 3 equals b to the first. So now we know that our rule is g of x equals 2 times 3 to the x plus 1. Okay, we will be doing a lot of these in class. Make sure to step through these out loud, talking about it, so that you get to process it. This comes handy when we have actual loans that we're going to get compounded yearly. Or actually, I guess this must be going into a savings account. They're putting $5,000 in a savings account with an interest rate of 2% compounded annually. So we want to know, well, how would we write that? First thing is, we know that it's a growth rate because we're gaining interest. It's 2%, so we should be gaining money. The problem is sometimes people want to put 2% in as the growth factor. Growth factor would be our B value. But in actuality, 2% would cause it to go down really fast. So we need to realize going at a level amount is at 100%. If we're going to go up 2%, it's going to be above the 100. So our B value is actually going to be 1 plus 0.02, because it's the 100% plus 2%. Anytime it's growing, we need to add that 100% in. Now, we start with our A value at 5,000, and we're going to want to know after 6 years, so we would raise it to the T value, and this would be the account balance depending upon the time. So in your graphing calculator, you can enter it 5,000, 1.02, go ahead and add those, raised to the 6th to see how much money you have in 6 years. Okay? Good luck with this. It's pretty fun stuff, and it's very, very useful to know exponentials. Thank you.